All right. Good morning, teenagers. This video is made Tuesday morning. It is February the 4th, and I will not be in class today because I have work to do with the union at the district office. I am making this video to fulfill my promise that I would work some problems of your request for you. Here's the note from Mr. Knight. Oh, a second. Students in period 2. Oh, that's period 2. This is for 5th and 6th period, regular physics class today. What's written on the board is from conservation of momentum. There's a big number 2, and somebody wrote 1 through 12. 1 through 12 makes no sense because there aren't 12 of them. I don't know what you teenagers are thinking. So I'll do number 2 for you because that's the one I see up on the board in big letters, which is completely ridiculous because number 2 is the second one, and I did the first one. What is going on? Well, anyhow, whatever. I'll just do it. Here we go. I don't have time to mess around. A 4-kilogram bowling ball sliding to the right at 4 meters per second has an elastic. That means it bounces head on collision with another 4-kilogram bowling ball initially at rest. So I'm going to make my initial picture. V1 initial, 8 meters per second. I'm going to call this direction positive. So this will be negative. This will be positive. And then this one, V2 initial is equal to 0 meters per second. Then final. How could you have trouble with this one? This one's too easy. Because the first ball stops after the collision. I know the answer off the top of my head just by looking at the question. The answer is 8 meters per second. Whatever. So, there's no way this is your actual question. If this is your actual question, you don't understand anything I've done for the last 2 weeks, which is sad. So V1 finally is equal to 0 meters per second, and V2 finally is unknown. Look, kids, just by law, I can't believe that this is the one you asked. Is that really the question that you asked me? It says number 2, conservation of momentum worksheet. This is the conservation of momentum worksheet. Well, I don't understand. Okay. The sum of all momentums initially is going to, there are 2 objects. So it's momentum 1 plus momentum 2. Momentum 2, the velocity is 0, so there is no momentum 2. So it's going to be mass 1 initially, velocity 1 initially, which is equal to 8 times 4, which is equal to 32 kilogram meter per second. So my initial momentum is 32 kilogram meters per second. That by conservation of momentum, the sum of all momentums initially is equal to the sum of all momentums finally. Also, by the definition of momentum, the sum of all momentums finally is equal to M1 finally, V1 finally, times plus M2 finally, V2 finally. V1, it stopped, so this entire term goes away to 0. So we've got momentum finally is equal to M2 finally, V2 finally. So V2 finally is equal to P sub F over M2 sub F, which is equal to 32 divided by 4, which is equal to 8 meters per second. So the answer is 8 meters per second, which I knew the second I read the stupid thing, because they have the identical mass, and this one is stopped at the beginning. The second one is stopped at the beginning. The first one is stopped at the end, which means all the momentum the first one had got transferred to the second. And since they're the exact same mass, that means the second one has to have the exact same velocity that the first one had. So I have now worked it out completely, and I am completely astonished that this is your question. So conservation of momentum, kids, that's what the topic is about. Whatever, that's the one question you wanted to ask me. And I am troubled because you have to have this worksheet completely finished. This was supposed to have been completely finished when I checked it on Friday or whatever, or Thursday. I checked this, and this should be done. I don't know why you're asking questions about this. This one is supposed to be due tomorrow, and you asked me no questions on this one. This is the one you're supposed to be worked on tomorrow. This is the one you're supposed to be working on yesterday. I have no idea what's going on with you, but I will find out tomorrow, that's for sure. So this one, conservation of momentum, is finished. You asked me a question about it for whatever reason. This one is 1 through 12. So you wanted all these done. Right. I'll do one of them for you. I have a couple more minutes. Let me just choose one. Okay. A freight train moves due north with a speed, let's call north positive. And it's got a speed of 8 meters per second and a mass of blah, blah. How fast would, this is super easy. Okay. So the momentum of the train is equal to mass times velocity. Mass is 6 times 10 to the 6th times velocity is 8. Oh God. So that's the momentum of the train. The momentum of the automobile has to have the same momentum of the train. So and that has to be equal to mass times velocity. So therefore, velocity must be equal to 4.8 times 10 to the 7th divided by the velocity, which, divided by the mass, which is 1,500. You get 32,000, which is completely ridiculous, but the correct answer. There. Good luck. Have this worksheet finished when I see you tomorrow. All right, got to make another video for another class. Have a great day.